Introduction to non-traditional machining. So far, we have been discussing about the traditional machining methods like turning, milling, drilling, etc. But from this lecture onwards, we shall start with non-traditional machining. And in this lecture, we will discuss the basic introduction to non-traditional machining. This is Dr. Gurraj Singh. So we'll start with the introduction to non-traditional machining, which we'll refer to as NTM. We'll go through the need for NTM, then the different types of NTM, the classification of machining methods, and the difference between conventional and non-conventional machining. So we have been talking about conventional cutting so far, where you're either turning or you're milling. So you can clearly see here at the bottom there's proper machining process going on, there's chips being removed. So all the traditional methods that are used for machining, they use a specific cutting tool, and what happens is that there is direct contact between the cutting tool and the workpiece. And traditional processes such as drilling, turning, shaping, milling, they are difficult to use on extremely hard and brittle materials. Now, this is from where the concept of non-traditional machining originates. What you're looking for is to cut extremely hard and brittle materials using cost-effective reasons. Now, why do you need non-traditional machining? There are three basic reasons. The first is that your materials are very hard, or they are very fragile, and they are difficult to clamp. So in this case, you would shift from traditional to non-traditional machining. Or if your workpiece is overly flexible or thin, so not only for stronger materials, for exceptionally weaker materials as well, you need non-traditional machining. And thirdly, when the shape is extra complex. Now we have discussed that you can produce several complex shapes, for example using the milling process. But there are some cases where the shape is even more complex that it cannot be taken care of using processes like milling. So to meet the extra machining conditions, several types of non-traditional machining processes have been developed. And when used correctly, these processes have many advantages over the traditional machining processes. So what is the need for non-traditional machining now? Now we know that the strength of steel alloys, it has increased over 5-folds as a result of the ongoing research and development, and that has led to the development of non-traditional cutting methods. Then in the aerospace industry, with the development or with the need for high strength and high temperature alloys while retaining a lower weight, it has led to the use of hard titanium alloys, mnemonic alloys, and HSTR alloys as well. So in light of all this, we have started looking for better methods, and non-traditional methods, they cater to our needs. Then the ultimate tensile strength, it has also increased by over 20 times. Further, the development of cutting tools with the hardness ranging from 80 to 85 HRC that could not be machined economically using traditional methods has led to the non-traditional machining methods. So when you're machining very hard materials, you are bound to have damage in the tools. And when your tool gets damaged very frequently, that process, it can be highly uneconomical. So instead of incurring those tooling costs, it is much more viable to start using the non-traditional machining methods. Now when you want to have intricate shaped holes, you want to machine difficult to machine material, then for low stress grinding, then for drilling deep holes with a small diameter, and for machining of composites. So these are the areas where you prefer using non-traditional machining. So these are some of the common areas where you would go for non-traditional machining instead of the traditional methods. So what are the various types of non-traditional machining? So first of all, let us define non-traditional machining. So NTM, it is a group of modern machining methods that uses electricity, heat energy, light energy, electrochemical energy, chemical energy, sound energy, and special mechanical energy to remove, deform, or change the properties, or even plate different materials. So in case of your traditional methods, all you're using is the rubbing, the shearing effect of a tool on the workpiece. But in this case, in the modern machining, you are using electricity, heat, light, chemical energy, electrochemical energy, and even sound energy in some of the cases to machine the materials. And you're not simply removing the material, you can deform the material, you can change the properties of material, you can even plate the materials. So when you talk about the traditional methods, you have your mechanical machining methods. In case of non-traditional machining, you have your mechanical machining methods, and under mechanical machining, you have ultrasonic machining, water jet machining, abrasive water jet machining, and a process called as ice jet machining. So these methods that we'll be taking on in much detail in the coming classes are used for mechanical machining. Now when I talk about thermal machining, where you're using heat energy, so you have electric discharge machining, which is EDM, which is a very important method that is being used these days, electron beam machining, laser beam machining, ion beam machining, and plasma beam machining. So these are all the methods that use heat energy. And then lastly, for chemical and electrochemical methods, we have chemical machining, photochemical machining, and electrochemical machining. So these are the electrical or the electrochemical methods. So these methods, they have led to the reduction in the machining costs and also much improvement in the cycle times, because when you're machining a traditional machining technique, you're using it on a very high strength material, a very hard material. It also takes a lot of time. So your cycle times, they also increase. But what these non-traditional methods have done, they have reduced the overall cost of machining. Although the initial cost of the setup might be high, but the cost of machining, the cycle time, it has gone drastically down. So if you classify machining, you can classify it as either conventional or non-conventional machining. Now the part dealing with conventional machining, on to the left, we have already discussed it in the previous lectures. Now conventional machining, it can further be split up into the machining where you're using chipping as the material removal method and producing a definite geometry tool. So your tool is having a definite geometry and it is chipping your material from the workpiece. And then you have the abrasion methods where you're using a non-definite tool and you're using abrasion as means of material removal. Now in chipping, you're producing either cylindrical or non-cylindrical workpieces. So when you're working on cylindrical workpieces, your processes that you're using, we have already discussed, they can be turning, boring, drilling, reaming. So these are the methods that are used on cylindrical workpieces. Now when I talk about non-cylindrical workpieces, you are using milling, shaping, planing, sawing, broaching, hobbing. So these are the methods that are used on non-cylindrical workpieces with chipping as the mode of material removal and a definite geometry tool. On the other hand, when you have a non-definite geometry tool, you can either use a bonded abrasive or a loose abrasive. Now the processes that use a bonded abrasive, they are grinding, which uses a grinding wheel, honing, which uses a specially designed honing tool, and super finishing, which uses a belt or a stone. On the other hand, we have loose abrasive techniques which are used in lapping, polishing, or buffing. So these are all the conventional methods. And likewise, when I talk about non-conventional methods, you have abrasion, which is performed using microchipping. And these methods, ultrasonic machining, abrasive jet machining, water jet machining, abrasive water jet machining, ice jet machining, and magnetic abrasive machining. And then we have the chemical disintegration, which is done atom by atom. We have chemical machining, photochemical machining, and electrochemical machining. And then we have the thermal methods where thermal erosion is done onto the workpiece, and melting basically takes place, or we can say direct vaporization takes place, we have four methods: electric discharge machining, electron beam machining, laser beam machining, and plasma arc machining. So these are all the techniques that we are going to talk about in the coming lectures. Before we can start with these techniques in detail, it is very important to know the basic difference now between conventional and non-conventional machining. So in case of conventional machining, you have a direct contact between the tool and the workpiece. In case of non-conventional machining, there is no direct contact between the tool and the workpiece. The cutting tool in case of conventional machining is always harder than the workpiece. So if you are trying to machine titanium, you cannot use a tool that is made up of, say, aluminium or a softer version of steel. You will always require a much harder tool. But when you are using non-traditional methods, your cutting tool need not be harder. Rather, your cutting strategy is entirely different as compared to the traditional methods. Then, the cutting material, it comes out in small pieces in the form of chips. But in case of non-traditional methods, it generally comes out in powder form or very, very small pieces. Then the energy used to remove the material is primarily mechanical. So we only use mechanical energy in case of traditional methods, but in non-traditional methods, we can use mechanical, electrical, thermal, or even chemical energy. So hard materials like ceramic, titanium, they cannot be machined using the traditional machining methods. But in case of non-traditional methods, you can machine the much harder materials. Then, tool wear. It is a concern, and the result, tool life is reduced. But in case of non-traditional machining, the tool life is extended because there is no contact between the tool and the workpiece. Traditional machining is not suitable for small-scale machining. But in this case, non-traditional machining can be used for small size machining. For example, you can drill micro holes using non-traditional machining. Unsatisfactory surface finish is achieved in traditional machining, but the non-traditional methods, they give a much better surface finish. It cannot make micro holes, so this is pretty much related to this point. And it can make, so non-traditional methods, they can make micro holes. And the example of conventional methods, well, we've already discussed lathe, drilling, milling. So these are the traditional machines, I'd rather say. And in case of non-conventional or unconventional machining methods, you have processes like abrasive jet machining or ultrasonic machining or water jet machining. So there are many methods that we'll be taking on in the coming classes. So this is a basic introduction to conventional versus non-conventional machining. And in the coming lecture, we would be discussing all the methods that are used in the non-conventional processes in much detail. Thank you.